hammer and the nail. The hammer and the nail will illustrate this kinetic energy, but in the reverse order. You read first, then I will explain to you. You read this first.
Um,
For example,
for example, suppose a hammer is on the verge of striking a nail, as in figure 5.9. The moving hammer has kinetic energy and can therefore do work on the nail. The work done on the nail is F, the X, where F is the average of the net force exerted on the nail, and triangle X is the distance the nail is driven into the wall. That work plus small amount of energy carried away by heat and sound is equal to the change in kinetic energy of the hammer.
okay. So I need to this okay, carried away. Okay. So I explain this situation to you. Now, when the hammer hits the nail, the nail will penetrate the wood. It will move in a further distance. I I say, let's say, a further distance of, okay, the further distance here means like this, huh? This one, let's say this is the distance. You will penetrate this distance, and this distance we call it delta x. This distance you will penetrate the thing, penetrate delta x. Okay. Your book happen to use this delta, the triangle delta x. So when the nail penetrates the wood by a distance of delta x, right? So there will be work done, there will be work done here because there's a movement, a displacement of delta x by a force F, right? So there will be work done here. Now coming back to the hammer. Now this hammer is moving with a velocity of v. It's moving with an initial velocity of v. Then the final velocity, the hammer will come to a rest. So when the hammer comes to a rest, the final velocity v naught, the final velocity will, although this is initial velocity, sorry, the final velocity will be like, the final velocity will be zero. Why so small? Oh dear. The final velocity will be zero, right? So
Mhm.
this is the situation, right? At first, the hammer is moving with a velocity of v. Finally, when the hammer hits the nail, the hammer will come to a stop. So this kinetic energy, which is half mv square, is totally lost because the hammer will come to a rest. At first, v, finally 0. Now, this kinetic energy, they say the kinetic energy of the hammer is used to do work. What type of work? Pushing the nail into the wood by a distance of delta x. And when they push the nail, they have a certain force called F. So when this F moves through a distance of delta x, there will be work done. And where does the energy for doing work come from? The energy for doing work comes from the kinetic energy of the hammer. Any question?
No question, sir.
No question. So this case, the hammer knocking against the wood is the opposite of this case. Is the opposite of this case. This case means they do work. They use the force. They pull it at the distance of delta x. So the work done is converted to kinetic energy in this case. But in the second case, the hammer is moving. Finally, the hammer come to a stop. There is work done. Where the work done goes to? The work done go in pushing the nail into the wood. They use a force of F, push the nail through a distance of delta x. Okay, so this the reverse lah. These two cases, they are the opposite of one another. Okay.